the chances of it being ignored are very, very high. Number two is, the recording will be available on YouTube, and we have also made a facility of having this particular live stream on YouTube as well. At the end, after this webinar is over, Dr. Sushila Venkatraman, my colleague, will wrap up and close. Today is the 5th of September, celebrated as Teachers' Day in India. And we are privileged to have 3 dons, as they say in Oxford and Cambridge, to be part of this webinar. September 5th is celebrated as Teachers' Day, like I said. And in honor of our former president, Dr. Radhakrishnan, who made a very interesting quote. He said, "Man is a paradoxical being, the constant glory and scandal of this world." I'm sure as we listen to Lord Rees and Dr. Srinivasan, we will realize the truth in this statement. With that, Professor Mishra, over to you.
Good evening to all of you, and good morning to those where it's morning, and good afternoon to people in the UK and the continent. It's absolutely a privilege to have Professor Lord Martin Rees for delivering our 20th webinar. 20 also marks a landmark that we have gone to the 20th webinar. Lord Martin Rees is the Baron of Ludlow, Astronomer Royal since 1995, I believe, or 2005, and an Emeritus Professor of Cosmology and Astrophysics at the University of Cambridge, England. He was the President of the Royal Society from 2005 to 2010, and he was former Master of Trinity College, Cambridge University from 2004 to 2012. It is during this period when he was the Master, I had occasion to be a visiting fellow at Trinity College and had very interesting conversations with Professor Martin Rees at that time. Professor Martin Rees obtained his PhD at Cambridge University in 1967 and went on to become one of the world's leading theoretical astrophysicists and a very senior figure in UK science. His research on the formation of the galaxy and black holes, amongst other things, addresses the big questions and provides key evidence to contradict the steady state theory of the evolution of the universe. Much of his most valuable research has focused on the end of the so-called cosmic dark ages, a period shortly after the Big Bang when the universe was yet without light sources. He received his knighthood in 1992, and for his services to science, he was further elevated to the title of Baron Rees of Ludlow in 2005. Lord Martin Rees is a prominent scientific spokesperson and the author of several books on popular science. He is the recipient of several prestigious awards that include the Templeton Prize in 2011, and this is given for harnessing the power of the sciences and explore the deepest question of the universe and humankind's purposes. In 2005, he received the, again, prestigious Crawford Prize, which is given in the field of astronomy for contributions towards understanding the large-scale structure of the universe. Many, many awards are there. I don't want to take too much time. But in 2007, he delivered the Blackett Memorial Lecture and the Jagdish Chand Bose Memorial Lecture, which was established by the Indian National Science Academy and the Royal Society. His lecture was on our final century, Will Civilization Survive? He is the former president of the British Association for the Advancement of Science, the president for the Royal Astronomical Society, as well as a trustee of the British Museum, the National Museum of Science and Industry, and the Institute for Public Policy Research. His views, wisdom, and forecasts on future technological developments give hope for the human ability to use science to repair our deeply wounded planet. This is acknowledged by the entire scientific community as well as key policy makers who understand the dangers we are heading towards. And today we'll hear from him about the world in 2050 and beyond. It is now my pleasure to introduce Dr. Ganeshan Srinivasan, our moderator for today's webinar. Dr. Ganeshan is an Indian physicist specializing in the field of condensed matter physics and astrophysics. He is a former professor from the Raman Research Institute, Bangalore. He received his PhD from the University of Chicago. Then he worked at IBM Research Laboratory in Zurich, Switzerland, and then worked at Chambers University in Gothenburg, Sweden, and the Cavendish Lab in Cambridge University. He was elected a Fellow of the Indian Academy of Sciences in 1984. He was IBM Fellow during 1971 and 72, then Jawaharlal Nehru Fellow during 2007 to 10. Professor Srinivasan was the president of the Commission 44 on High Energy Astrophysics of International Astronomical Union from 1997 to 2000, and president of the 11th of the Division 11 of the IAU on Space and High Energy Astrophysics, and also the president of the Astronomical Society of India. It's really a privilege to have Lord Rees present this webinar today, whom I've known now for several years, and it's very gracious of you to have accepted our invitation to address this webinar of the IIT Alumni Center. We're all looking forward to it, and over to Ashok Kamath again before your lecture starts.
Professor Mishra, would you like to launch the first volume of the webinar along with Lord Rees?
Okay, so let me mention one line about it. We have had, this is the 20th webinar. What we decided is that we would have a record of all the webinars, which will also go in our archives and so on. So with a lot of effort put by my colleague Ashok Kamath, we have come up with the first volume of the IIT Alumni Center webinars with the first 10 lectures, the first 10 webinars, including question and answers and so on. So this is, we would like to launch it on this very good day of Teachers' Day and with in the presence of Lord Rees. So can we launch it, Martin, together? This is the book. We have to do this all virtually. And this book will be available to people through the internet on the web.
All right.
So over to you, Lord Rees, for your exciting lecture. We look forward to it.
Right. Well, let me say what a pleasure and privilege it is for, can you hear me?
Yes, we can.
Okay, privilege to be able to address this audience, which contains many of my friends from India, but also many others. So it's good evening, everyone, and good afternoon from me. And I'm going to talk about, in a sense, an update of the Blackett lecture you mentioned. I'm going to talk about the problems we are confronting this century, the world in 2050 and beyond. So let me see if I can share my screen. Minutes. Yes. Yes. Okay. And so this is my first slide. Well, let me start off by saying that it was mentioned that I have the title Astronomer Royal, and I'm sometimes asked, does this mean you do the Queen's horoscopes? I have to say she's never actually asked me. But in any case, I want to emphasize that I'm just an astronomer, not an astrologer. I've got no crystal ball, and scientists are actually rather bad as forecasters, although I would say they're not quite as bad as economists. But I have nonetheless written a book. Now I'm not able to advance my slides now. No, so when we tested this, I could advance my slides very easily, but I now can't.
Do you want me to do that for you?
If you can, but that will be on will it be on the ones from my machine?
No, it will be from my machine. I have a problem.
No, but they turn out to be a bit different. So let me. Okay. Did you do that or did me?
No, you did it. You did it.
Okay. So let me just see. No. Okay. So I'm okay now. Sorry. So sorry to the audience for that technical handicap. As you can see, I'm a late adopter of technology, and young people are far better at that. Well, as I was saying, I have potentially written a book with this title, On the Future, but my forecast will be very tentative. But the theme of my book is this, that the Earth existed for 45 million centuries, but this century is special. It's the first when one species, ours, has the planet's future in its hands. We're deep in what's sometimes called the Anthropocene. We could irreversibly degrade the biosphere, or we could trigger a transition from biologics to electronic life. Or misdirected technology could cause a catastrophic setback to civilization. But even with a cloudy crystal ball, there are some things we can predict. For instance, by 2050, the world will be more crowded and it will be warmer. So just a word about population trends. 50 years ago, the world's population was about 3.5 billion. It's now about 7.8 billion. And the growth has been mainly in Asia and Africa. And this distorted map gives each country a size which is proportional to the number of extra people in the last 30 years. And as you can see, it makes East Asia, China and India and Africa much larger than Europe and North America, because they are the countries where the population growth has been the greatest. Now, we can't extrapolate this because the number of births per year worldwide has actually been going down for the last few years. And it's going down in most countries, but not quite in all, certainly not in sub-Saharan Africa. But even despite that, the world population is going to go up and will be, according to most projections, about 9 billion by middle of the century. And that's partly because most people in the developing world are young, they're yet to have children, and they will live longer. And the age histogram on the left, which is the age distribution in West Africa, where there are lots and lots of young people and very few old people, will get more like what it is in Europe, which is on the right. So the people at the bottom, the left-hand one, they'll still be alive, and so even if they only have 2 children, the world population is going to grow, particularly in areas like West Africa. Well, back in the 1960s and 1970s, there were doom-laden forecasts by the Club of Rome and by people like Paul Ehrlich about potential rising population. But food production has kept pace with the rise in population in the last 50 years. Famines still occur, sadly, but they're due to conflicts, wars, or to maldistribution, not to overall scarcity. But to feed 9 billion by mid-century is going to require further improved agriculture. And of course, I wouldn't say what should happen in India, but of course it's going to be different in different countries. But in many countries, one's going to have to worry about using less water, perhaps using genetically modified crops to have more intensive agriculture, and indeed maybe in some parts of the world have dietary innovations, converting insects, highly nutritious and rich in protein, into palatable food, and perhaps creating artificial meat. Because certainly we can't have 9 billion people all eating huge beefsteaks like present day Americans, obviously not. So to quote Gandhi, there's enough for everyone's need, but not for everyone's greed. The diet will have to change. Certainly the European North American diet will have to change over the next 20 or 30 years. Population projections after 2050 are uncertain. It's not even clear whether there'll be a global rise or fall. Falling infant mortality, urbanization and women's education, of course, triggered the so-called demographic transition towards lower birth rates. But there could be some countervailing cultural influences. Maybe in Africa, for instance, large families will still be favored. And if that happens, then according to some UN projections, the population of Africa will be 2 billion by 2050, but could double again by 2100 to 4 billion. If that happened, then Nigeria, just one country in Africa, would have a population of 900 million, which would be equal to the population of Europe and North America combined. So a massive redistribution of the world's people. And I think Africa is going to have a problem to get out of the poverty trap. I won't go into that because one problem is that the way in which Asian countries undercut Western manufacturing costs has been taken away because robots are doing the manufacturing now. So it can't be undercut by Vietnam and places. And also, I worry about the stability of the world because in Africa, the one technology they do have is mobile phones. So they know what's missing, they know the injustice of their fate. And so unless the wealthy countries, especially in North America and Europe, have a sort of massive aim to help Africa, then I think we're going to have huge migration and war triggered by justified embitterment at the fate of Africa. Well, that's a digression. So let's hope that politicians can sort this out and ensure that the gap between the most favored and least favored nations narrows, not widens. Well, so much for population. Now, another thing. If humanity's collective impact on land use and climate pushes too hard, then the resultant ecological shock could irreversibly impoverish our biosphere. Extinction rates are rising. We're destroying the book of life before we've read it. Now, biodiversity is, of course, crucial to human well-being. But for many environmentalists, preserving the richness of our biosphere has value in its own right, over and above what it means to us humans. To quote the great ecologist from Harvard, E.O. Wilson, mass extinction is the sin that future generations will least forgive us for. The other prediction, apart from the world getting more crowded, is that the world is getting warmer. And the basic evidence for this comes from this picture here. This is the so-called Keeling curve, which represents the concentration of carbon dioxide in the atmosphere measured from a mountaintop in Hawaii over the last 50 years or so. It's in parts per million, and you can see that over that period, it's risen by nearly 50%. It's still going up. The oscillations every year, incidentally, they come about because there are more trees in the northern hemisphere than the southern hemisphere. So in the autumn in the northern hemisphere, the leaves fall off the trees, that puts carbon dioxide back in the atmosphere, and then in the spring, it's sucked back in again into the new growth. So that's the oscillations, but the important thing is this trend. And there's no doubt about this, this rise in carbon dioxide. And also, there's no doubt, it's been known since the 19th century, that carbon dioxide is a greenhouse gas. It traps heat in the atmosphere and warms it up. And so this is, of course, a big concern. And the International Panel on Climate Change, the IPCC, has presented in its recent report a range of projections for different assumptions about the future rates of fossil fuel use around the world. And it's still unclear, incidentally, two things about this picture. First, of course, we don't know which scenario we will follow. It depends on how quickly we can abandon the use of fossil fuels, and on the other hand, how many coal-fired power stations are built. But also there are intrinsic uncertainties, because carbon dioxide is not the only thing in the atmosphere. And as carbon dioxide changes, the atmosphere warms, then cloud cover changes, there's more water vapor, etc. So the bars at the right-hand side of this picture illustrate the range of uncertainty for a given model, which is uncertainty because the models of the atmosphere are uncertain. But the message here is that the climate is changing, it's getting warmer, and that despite the uncertainties, we can agree that under business as usual scenarios, we can't rule out later this century really catastrophic warming and tipping points triggering long-term trends like the melting of Greenland ice and shifts in the weather patterns globally, in the monsoons and all that, droughts in different places, etc. Well, of course, as everyone knows, there are international discussions every year about how to mitigate this global warming. But of course, it's very hard to get politicians to prioritize this, because they won't prioritize issues where the benefits accrue mainly to distant parts of the world and are decades in the future. They have urgent issues to worry about. But they will only take actions to reduce these long-term threats if there's public pressure, if they know the public's behind them. And that's why we should welcome the demonstrations that have been happening, certainly in European countries, especially for young people, because young people will still be alive at the end of a century. And we ought not to discount the future, as some economists do, and say it doesn't matter what happens after 2050. We should not discriminate on grounds of date of birth. We should care about the life chances of a baby born today, your grandchildren who will be alive then. And we shouldn't discount their future. And that's why we should welcome charismatic individuals who help to spread this message. And one of them, certainly in my country, is David Attenborough, whose TV programs have influenced millions. And incidentally, he has drawn attention to another issue, which is the effect of plastics in the ocean. And in our country, a not very enlightened minister has actually introduced legislation to ban the use of non-reusable plastics in food production and drinking straws and things. And he wouldn't have done that had it not been for the fact that millions of people had watched television programs, Blue Planet. I'm not sure if they've shown in India, but they had some wonderful shots of albatrosses and one returning to its nest after wandering the Southern Ocean and coughing up for its infants, not the longed for nourishment, but bits of plastic. And that became an iconic image for many millions in England, rather like the polar bear on the melting ice floe has been for climate campaigns. And so if the public supports these long-term campaigns to make the environment safe for next generations, then politicians will listen. But I will mention that there is one win-win roadmap to a low-carbon future, which doesn't involve any hardship, and that's that nations should accelerate their research and development into all forms of low-carbon energy generation and into other technologies where parallel progress is crucial, especially storage, batteries, compressed air, flywheels, and smart grids. And the faster these technologies advance, the sooner will their prices fall, so they become affordable. And in India, there's clearly a need for more energy because you're using now about 5 times less energy per person than in Europe, and clearly you need more. But the hope is that you'll be able to leapfrog directly to clean carbon-free energy rather than building too many coal-fired power stations. And that will happen if R&D into more advanced kinds of clean energy advance fast enough that the costs come down. And I guess the main extra demand is going to be for air conditioning, etc., and solar energy. So if that comes down so that you don't need so many coal-fired power stations, that's going to be good for the world. And so I think a worldwide effort to speed up research and development so that the whole world can develop from clean energy at a low cost is a very important priority. And indeed, it would be hard to think of a more inspiring challenge for young engineers all around the world than devising clean and economical energy systems. Incidentally, I talked about science early, but I include engineering. And perhaps I should mention that as a scientist, I'm very modest about engineers. Engineers like an old cartoon from the New Yorker, I think, which showed 2 beavers looking up at a big hydroelectric dam. One beaver says to the other, "I didn't actually build it, but it's based on my idea." And that nicely reflects the balance of effort and brain power between having the idea and implementing it in something that works. So people who are armchair theorists should be very modest compared to those who actually build things that work. And that's mainly the engineers. And we should be evangelists for new technology, because without it, the world can't provide food and sustainable energy for the expanding and more demanding population. But many of us are anxious that technology is advancing so fast that we may not properly cope with it, and that we'll have a sort of bumpy ride through this century. We're ever more dependent on elaborate networks, electric power grids, air traffic control, international finance, just-in-time delivery, globally dispersed manufacturing, and so forth. And unless these networks are highly resilient, their manifest benefits could be outweighed by catastrophic, albeit rare, breakdowns, real-world analogues of what happened in 2008 to the financial system. Cities will be paralyzed without electricity. Shelves will be empty within days if supply chains were disrupted. And air travel can spread a pandemic worldwide within a few days. And social media can spread panic and rumor and psychic and economic contagion literally at the speed of light. Pandemics are, of course, at the forefront of our concerns today. They have emphasized just how interdependent we all are. Advances in microbiology, in diagnostics and vaccines, etc., offer prospects of containing them in the future. Let's hope they do. But that same research, we've got to be aware, will have downsides. This is a picture not of the coronavirus, but of the influenza virus. And back in 2012, 2 research groups, one in the United States, the other in Holland, showed it was surprisingly easy in a lab to make this virus both more virulent and more transmissible. And to some, this was a scary portent of things to come. The COVID-19 virus, incidentally, is more complicated, but we can't rule out in future scenarios where viruses like that can be engineered too. And another exciting new technology is what's called CRISPR-Cas9, which is a way of editing the genome. This is hugely promising, and it can be used already to remove a particular gene that causes rare diseases in humans and animals. But there are ethical concerns. There were very much concerns about a recent Chinese experiment on human embryos. It's not yet safe to use these techniques. There's also concern about possible runaway consequences of gene drive programs to wipe out species. For instance, it's been possible to wipe out the kind of mosquito which carries the Zika virus in South America by modifying the genome of the mosquito to make it sterile. That can be done, but of course, tampering with ecologies can have runaway consequences which you can't predict. So biotech, getting so powerful, needs to be regulated. And of course, there are discussions between governments and between academies about how this should be done. But I'd worry that whatever regulations are imposed on grounds of prudence or of ethics can't be enforced worldwide any more than the drug laws can or the tax laws. Whatever can be done will be done by someone somewhere. And that's a nightmare, because whereas an atomic bomb can't be built without large-scale special purpose facilities, biotech involves small-scale dual-use equipment. Indeed, biohacking is burgeoning even as a hobby and competitive game. And as I put it, the global village will have its village idiots, and they'll have global range. And the rising empowerment of tech-savvy groups, or even individuals, by bio as well as cyber technology, will pose, I think, an intractable new challenge for governments and aggravate the tension between three things we want to preserve: freedom, privacy, and security. These concerns are fairly near term, within 10 or 15 years. What about 2050 and beyond? On the bio front, we might then expect two things. First, a better understanding of the combination of genes which determines key human characteristics. And second, the ability to synthesize genomes that match these features. And in fact, the great physicist Freeman Dyson conjectured a time when children would be able to design and create new organisms, just as routinely as his generation played with chemistry sets. Well, if it does become possible to, as it were, play God on a kitchen table, our ecology and even our species may not long survive unscathed. And what about another transformative technology? Robotics and artificial intelligence. There have been exciting advances, as you probably know, in generalized machine learning. The DeepMind company's computer, AlphaGo Zero, famously beat the world champion at the game of Go. It was given just the rules, and it learned to play better than him in just a few hours. Its huge processing speed allowed it to carry out one game every few seconds. Well, AI can do many things that are helpful to us. It can cope better than humans with complex, fast-changing networks, traffic flows or electric grids, for instance. It could enable the Chinese to process all the information needed to run an efficient planned economy of a kind that Marx could only dream of. And in science, its capacity to explore millions of options could enable it to discover recipes for better drugs, or material that conducts electricity with zero resistance at room temperature, or perhaps help theorists in string theory to understand whether their theory is correct, because the geometry of 10 dimensions in those theories may be too hard for a human person in a lifetime to work through. And it is, of course, the speed of computers which allows them to succeed by brute force methods. But they learn by playing lots and lots of games and by having big training sets. But this leads to some problems when humans depend on them, because learning about human behavior involves observing real people in real homes or workplaces. And the machine would feel sensually deprived by the slowness of real life. It's like us watching trees grow. And that's why it's hard to give computers common sense. And this is a reason why we should be careful about handing over decisions to them. And incidentally, robots are still clumsier than a child in moving pieces on a real chessboard. They can't jump from tree to tree like a squirrel. Though Boston Dynamics has produced this robot, which can apparently do somersaults and a bit of gymnastics, though in a rather clumsy way. And the Go playing computer used hundreds of kilowatts of power. But the brain of the human challenger, who I showed, burns about 30 watts, the same as a light bulb. And he can do many other things apart from play Go. So AI has a long way to develop, but its systems will become more intrusive and pervasive. Records of all our movements, our health, and our financial transactions will be in the cloud, managed by a multinational quasi-monopoly. The data may be used for benign purposes, for instance, for medical research or to warn us of incipient health risks, but its availability to internet companies is already shifting the balance of power from governments to globe-spanning conglomerates. And of course, computers are already changing the nature of work. There are many books that have addressed this, and of course, they will replace some kinds of routine work in factories easily. But it's important that they can supplement and replace also many so-called white-collar jobs, routine legal work, accountancy, computer coding, medical diagnostics, and even surgery. But on the other hand, what will be hardest to replace by a machine are some skilled jobs like being a plumber or being a gardener, or maybe driving a car. I think it'll be a long time before we have fully automatic cars. And of course, the other problem is that the digital revolution is generating huge wealth for innovators and global companies. And I think preserving a healthy society will surely require redistribution of that wealth. In particular, many progressive politicians in Europe argue that to create a humane society, governments will need to tax these companies more heavily and enhance the number and status of those who do jobs where the human element is crucial, like helping teachers, looking after old people, etc. There are currently far too few such people in Europe, and they're poorly paid and inadequately esteemed. And those are far more fulfilling jobs than working in a telephone call center or an Amazon warehouse. But let's now look further ahead. How human-like will computers be in the future? What if a machine develops a mind of its own? Would it stay docile or would it go rogue? Popular culture portrays a dark side where AI gets out of its box, infiltrates the Internet of Things, and pursues goals misaligned with human interests, or even treats us as an encumbrance. Some AI pundits take this seriously and think the field already needs guidelines, just as biotech does. But others, like for instance Rodney Brooks, inventor of the Baxter robot, he regards these concerns as premature. He he thinks it'll be a long time before artificial intelligence need worry us more than real stupidity. But nonetheless, it's likely that society will be transformed by autonomous robots, even though the jury's out on whether they be idiot savants or display superhuman capabilities. This man, Ray Kurzweil, who now works at Google, he wrote a book called The Age of Spiritual Machines, where he predicted that humans would transcend biology by merging with computers. But he's worried that his nirvana may not happen in his lifetime. He's in his 60s already. So he wants his body frozen in liquid nitrogen when he dies. And there's a company in Arizona which will freeze and store your body so that when it's possible to revive you, when your immortality is on offer, you can be resurrected with your brain downloaded. I was surprised to find that 3 of my academic colleagues had paid for this, paid for their bodies to be frozen. Well, 2 had paid the full whack, 1 had paid the cut price to have his head frozen. I told these people I'd rather end my days in an English churchyard than an American refrigerator. And I'm glad to say that these 3 were all from Oxford University and not from my university. But of course, more seriously, research on aging is being seriously discussed. Will the benefits be incremental, or is aging a disease that can be cured? Dramatic life extension would, of course, plainly be a wild card in population projections with huge social ramifications. But it may happen along with human enhancement in other forms. So it's at least on the cards that human beings, their mentality and their physique, may become malleable through the deployment of genetic modification and cyborg technologies. Moreover, this future evolution, a kind of secular intelligent design, would take only centuries, in contrast to the thousands of centuries that was needed for our evolution by Darwinian methods. And this is a game changer. When we admire the literature and artifacts that have survived from antiquity, we feel an affinity across a time gulf of thousands of years with these ancient artists and their civilizations. But we can have zero confidence that the dominant intelligences a few centuries hence will have any emotional resonance with us, even though they may have some sort of algorithmic understanding of what we did and how we behaved. And now, in my final section, I want to turn to another technology, space, because it's beyond our Earth, in environments hostile to humans, that cyborg and AI technologies have the most spectacular scope and where they should worry us less. During this century, the whole solar system will be explored by swarms of miniaturized probes, a follow-up to the ones that have already been to most of the planets. And of course, there's an Indian probe that's gone to Mars, 3 more on their way at the moment. But the future ones will be far more advanced than, for instance, the wonderful Cassini probe, designed in the 1990s, which spent 13 years exploring Saturn and its moons, or the European Rosetta probe, which landed on a comet, or the NASA probe that sent back amazing pictures from Pluto, 12,000 times further away than the moon. All these were designed in the 1990s. And think of how much our smartphones have changed since then, and think therefore how much better we could design miniaturized probes to explore the outer planets today. And we can also look forward to giant robotic fabricators in space, building solar energy collectors, giant telescopes, etc. But what about manned spaceflight? It's over 50 years since Neil Armstrong's one small step. And I cherish this photo, signed for me by 7 of the Apollo astronauts. In the 1960s, of course, there was a space race between the Americans and the Russians. NASA got about 4% of the American federal budget. Had that pace continued, there'd have been footprints on Mars long before today. But having won the race, the Americans cut back, and NASA's budget is now 0.6% rather than 4% of their budget. But hundreds of more people have been into space, but anticlimactically, they've done no more than circle the Earth in low orbit, mainly in the International Space Station here. So will there be any inspirational Apollo-type project in future? There's no denying that NASA's Curiosity, this probe that has been trundling across Mars for the last 10 years, may miss startling discoveries that no human geologist would overlook. But machine learning is advancing fast. And I imagine that we'll have future robots that can be intelligent. In contrast, the cost gap between manned and unmanned missions becomes even larger. So the case for sending human beings is getting weaker as miniaturization and robotics get better. And I think, therefore, that the future of manned spaceflight lies only with privately funded adventurers prepared to participate in a cut-price program much riskier than Western nations could impose on publicly supported civilians. Elon Musk's SpaceX and Bezos's Blue Origin will soon offer orbital flights to paying customers. Indeed, were I an American, I would only support NASA's unmanned program. I'd argue that private enterprise ventures, bringing a Silicon Valley culture into a debate long dominated by a few aerospace conglomerates, should front all manned missions as cut-price, high-risk ventures. There'd still be many volunteers, even if you had a one-way ticket, by people driven by the same motives as early explorers, mountaineers, and the like. So I think that by 2100, some thrill seekers may have established bases independent of the Earth, probably on Mars. Elon Musk himself, who's age 49, says he wants to die on Mars, but not on impact, and he may succeed. But don't ever expect mass emigration from the Earth. Nowhere in our solar system offers an environment even as clement as the Antarctic or the top of Everest. And here I disagree with Musk and with my late colleague, Stephen Hawking. I think it's a dangerous delusion to think that space offers an escape from the Earth's problems. Dealing with climate change on Earth is easy compared to terraforming Mars. There's no planet B for ordinary risk-averse people. Nonetheless, we should cheer on these space adventurers because they'll have a pivotal role in spearheading a post-human future and determining what happens in the 22nd century and far beyond. That's because they will be in a hostile environment, they'll be away from all the regulators, so they will have the opportunity and the motive to adapt themselves, and so they will change from normal human form more quickly than those of us on the Earth. Well, those people, the descendants of the first Martians, may go off into blue yonder and into space. But this raises the question, which is the one that I most often asked, which is there life out there already? Or is the galaxy waiting for our progeny? Well, because some people know the answer. I sometimes get letters from people who say they've met aliens, they've been abducted. I say to them, do you really think that if the aliens had come to the Earth, they'd have just met one or two well-known cranks, maybe made a corn circle and gone away again? Seems unlikely to me. And I tell these people to write to each other and not to me. But nonetheless, it's an exciting question. Is there life out there? There may be some creatures, or at least remnants of simple creatures on Mars. The probes going there now may be able to detect this. There may be even some creatures swimming under the ice. Here, this is Enceladus, a moon of Saturn. But I think we know there's no complex life anywhere other than the Earth in our solar system. But let's widen our horizons to the realm of the stars. One important thing we've learned in astronomy is that most of the stars in the sky are orbited by retinues of planets, just like the sun is. The evidence is mainly indirect, just a little word about it. We don't detect a planet, but if we look at a star, then if a planet transits across in front of it, it'll block out a bit of its light. So if there's a planet, the star is going to dim every time the planet goes in front of it. So you can learn two things. You can learn how big the planet is compared to the star from the amplitude of the dip, and you can learn the planet's year by the period between successive dips. And this spacecraft called Kepler spent 3.5 years looking at an area of sky about 7 degrees across and measuring the brightness of about 100,000 stars very precisely, doing this about once every hour, looking for these regular dips. And it found evidence for literally thousands of stars with planets around them. And this rather silly picture depicts to scale the orbital period and the size of the planets. But there were thousands of them. And the special interest in planets which are rather like the Earth, the size of the Earth and a temperature where water can exist. And one thing we've learned from this sample is that almost every star has planets around it, and probably 1 in 6 stars has an Earth-like planet. And that means literally billions in the Milky Way and some around quite nearby stars. And just to give an example, this is a rather strange system. This is a system where there's a very faint star, 100 times fainter than the sun, called a red dwarf, and it's got 7 planets orbiting around it. It's a miniature solar system. The innermost one has a year, which is 1.5 Earth days, and even the outermost one has a year that lasts only a couple of weeks. And because the star is so faint, the outermost one is in the so-called habitable zone where water could exist. Well, we have this indirect evidence for planets from the transits, and also sometimes from the wobble they induce by their gravity in the most of the stars. But we'd like to see them directly. And let me emphasize what a challenge this is by imagining there were some aliens out there in space with a big telescope looking at the Earth. They would see the sun as an ordinary star. They'd see the Earth as a pale blue dot, in Carl Sagan's nice phrase, very close in the sky to its star, our sun, and billions of times fainter. But if they could nonetheless detect that pale blue dot, they could learn quite a bit about it. The shade of blue will be slightly different depending on if the Pacific Ocean or the landmass of Asia was facing them. So they could learn that there were continents and ocean, the length of the day, something about the seasons. And if they could take a spectra of the light from the planet, then they could perhaps infer that there was a biosphere, because chlorophyll has a particular spectral signature and oxygen and ozone do as well. Well, we can't yet do that, but this telescope, which is now under construction, it's being built by a European consortium in Chile, and they're not very imaginative in their nomenclature. It's called the Extremely Large Telescope, the ELT, and it's got a mirror 39 meters across, a mosaic of 800 pieces of glass. And this telescope, finished in 5 years, should be able to isolate the light from a planet from that of the star it's orbiting and do measurements rather like those I envisaged the aliens doing of the Earth to see if there's any evidence for chlorophyll or some sort of biosphere on any of these nearby planets. So watch this space. This is going to be a very, very exciting area of science in the next few years, certainly the next decade. Well, of course, we don't know how likely it is that there'll be life on these. Habitable doesn't mean inhabited. And indeed, we know very little about the origin of life on Earth. We understand evolution of life, but we don't understand what caused the transition from complex chemicals to the first reproducing, metabolizing systems we call alive. But we are making progress on that, and we will have some idea about whether that's common or not, perhaps. But of course, intelligent life is separate, and I'm not holding my breath for success there, although I should say that I chair a committee bankrolled by Yuri Milner, who's a Russian investor in California, who's putting $10 million a year into a search program to look for any kind of evidence for artificial signals or artifacts which might indicate intelligence. It's very good he's doing this rather than spending his money on a big yacht or a football team, but I don't hold out great hopes of success. Well, that's a topic for a different lecture. So let me just finish off by taking another perspective. I think most people are familiar with this time chart, that we are the outcome of 4 billion years of evolution on Earth, from the first simple life soon after the Earth formed to the present. But I think many people who are happy with this scenario somehow think we humans are the culmination. But no astronomers could believe that. That's because astronomers know that the sun is less than halfway through its life. It's been going 4.5 billion years. It's got about 6 more before it flares up and dies. And the expanding universe may go on forever. To quote Woody Allen, eternity is very long, especially towards the end. And that therefore means that we are not the end of evolution. We may be near the beginning. And future evolution may be flesh and blood. It may be post-human, electronic. We don't know. It's hard for us to predict even a few decades away. But my final thought is this, that even in the context of this concertina timescale on this picture, showing billions of years in the past and billions of years in the future, this century is special. It's the first in the Earth's 45 million centuries when one species, ours, has the planet's future in its hands. Our creative intelligence could jumpstart the transition from an Earth-based to a spacefaring species, and from biological to artificial intelligence, transitions which could inaugurate billions of years of post-human evolution, even more marvelous than what's happened up till now, here on Earth and far beyond. On the other hand, humans could trigger bio, cyber, or environmental catastrophes that foreclose all such potentialities. So this century is special. And our Earth, this pale blue dot in the cosmos, is a special place. It may be a unique place. We're its stewards at a especially crucial era. And that's, I think, an important message for all of us, whether we are astronomers or not. So let me finish with that thought. And thank you very much for listening.
Thank you, Lord Rees, for this most fascinating and also thought-provoking remarks. As always, when you give a lecture, whether it's on astronomy or cosmology or climate change or about the future, there were so many prescient thoughts that it requires very deep thinking. I wanted to pick your brain on 1 or 2 things that you mentioned and perhaps refer to in a tangential manner. In your recent book that you referred to, you predicted a pandemic, and here it is. the world has changed very profoundly during this pandemic, and we haven't seen the end of it. The economic fallout has been catastrophic. But the lockdown did have some positive effects. I see spectacular pictures in CNN very frequently of scenes in New Delhi, Shanghai, and other places. The left half of the image was how it used to look. The right half of the image is during the lockdown.
Mm-hmm.
The optical depth is practically zero, whereas on the left side,
Yes.
the pollution, you can hardly see anything, particularly in a place like Delhi.
Mm-hmm.
Then there was this spectacular picture in the newspapers in India of the river Yamuna, which flows through Delhi, and also the Ganges. As you know, the pollution level in these two rivers is horrific. And there's been talk by many governments, particularly this government, that they're going to clean it up in 5 days, 5 years, nothing has happened. But during the lockdown, the two rivers the water became so spectacularly clean.
Yes.
So here is my question to you. Do you think there is sufficient political wisdom in the various countries that people will learn from what happened during the positive thing that happened during the lockdown, so that we do not make some of the mistakes that we did in the past, particularly overemphasis on fossil fuels and things like that? Do you think there is likely to be any real change?
Well, the answer, I think, is yes. And in particular, environmental pollution. I think the fact that people realize how much better it is if that pollution is reduced is going to be surely a wake-up call. It's important to reduce that. And far more effective, I would have thought, to see this happening for real than David Attenborough preaching about it, or the Pope preaching about it. So I think it will have that effect. As regards the CO2 emission and all that, I think it's not quite so straightforward because, of course, the production was stopped during the lockdown and the use of electricity was lower, but that's probably going to revive, and it needs to revive. And so I think the issue of the shift away from coal-fired power stations to clean energy, especially if the number of coal-fired power stations is otherwise going to grow, that's a bigger challenge. But I think the important point is that politicians need pressure on the public. There was a European politician, Jean-Paul Juncker, who said, we know what the right thing is to do. We don't know how to get re-elected if we do it. And that's probably true in most countries, that to do something which benefits future generations, and that's certainly the case for dealing with climate change, is a hard sell unless the public is sensitized to its importance. But I think you're quite right that seeing the change in the environment during lockdown was certainly a big plus. And just one further point is that, of course, in England, there's a debate about whether people will go back to commuting into the centre of London 5 days a week, or whether they'll at least work partly at home. And I think probably there will be some irreversible reduction in the amount of commuting into cities, and knowing what the traffic's like in Bangalore, etc., I can imagine there might be some similar attitudes there.
You mentioned about the need for a diet change, that people will have to eat less juicy steaks. Now, one of the things that the Vice President of America is going around saying now is that if you elect the Democrats, you won't be able to eat your steak. Okay, so how realistic it is, and how do we go about educating the public? Because as you say, the politicians will do whatever is necessary to get re-elected. So it all comes down to how we educate the public. So do you have some thoughts on how one might go about this?
Yes, well, of course, here the problem is in Europe and in North America rather than in India at the moment.
I understand.
But I think education has some effect, and there's more vegetarian among the younger generation in Western countries, so that's changing. But of course, the other thing is that the idea of making artificial meat is not crazy. I mean, you can now get an artificial hamburger where they have beetroot juice instead of blood, etc. That's already on sale, but that's not quite the same. I won't satisfy the American steak eater, but it is possible to actually take one cell from a living animal and grow it on some template. And this is a technology which is being developed. And this seems to be a very benign technology. And if that can be developed, then it ought to produce synthetic meat which will satisfy meat eaters. And if that happens, then even the Americans may be happy to accept it. And that will make a huge difference, because the land needed to graze cows and all that would go right down. And it takes 16 times as much protein to produce meat than for vegetarian diet, because it's processed through the cow rather inefficiently. And
you mentioned artificial intelligence very prominently. Do you share the apprehensions that Stephen Hawking had about artificial intelligence, the dangers that it poses?
Well, I mean, I do worry if it takes over activities and can't be controlled. And of course, there's already a concern that AI is being used to make decisions which affect us as humans. And for instance, in some big companies, if they got 1,000 applicants for a job, the preliminary sorting is done by some machine to cut down the list. And it's also the case that much medical diagnostics is done by machine. And in a bank, it'll decide your credit rating by machine. And the trouble is that the machine learns by looking at large samples of existing data. And if that data has lots of biases in it, then the machine will learn the same biases. You've got to be careful about that. And the other point is that there may be some bugs in the machine. And for instance, supposing that you have to be recommended for surgery, or decided whether you will let out of prison on parole, things like that. Even if you're told that the machine on the whole makes better decisions than a human being, you're still not satisfied. You feel that when a decision affects you, then you ought to be able to understand the reasons and be able to contest those reasons. So I think we've got to fight against the use of AI to make decisions that affect us, to affect whether we need surgery, whether we're let out of prison, etc. So I think that's a short-term danger.
There are lots and lots of questions from viewers. Perhaps the most efficient way for me to pose the questions is to perhaps paraphrase them and condense them. When we first met almost 50 years ago, the way of life was very different in the world. There was no internet, there were no smartphones. And yet there's been no dramatic revolutionary discoveries in science which has led to this changed lifestyle. It is mainly technology. But then if we look at when Einstein was born, radio waves had not been detected. X-rays, nobody knew about X-rays or gamma rays. Mm-hmm. Wright brothers hadn't flown. Mm. So what do you think are the possibilities of one of the viewers asked the question, a phase transition like behavior in science, namely a very dramatic discovery which will lead to completely different types of evolution of technology. Do you think that's likely?
Well, I mean, I think it takes several decades, because going from the first transistor to the smartphone, that was 50 years or so. And if you think of biology, going from the double helix to what we have now, that's a huge advance. We can now synthesize the human genome and analyze it using AI, etc. So I think biological developments, which are going to raise huge numbers of ethical issues, they will develop fast. But I think another point I'd like to make is that most developments, they're not exponential. They're like a sigmoid curve. They go up fast, and then they level off. And you mentioned what our lives were like 50 years ago. We did the big transformation since then is the internet, smartphones, and all that. But the advances which had happened before that time, from say 1880 to the 1960s, they were far more important. The electricity, the car, the railways, domestic appliances, radio, television, etc. They were far more transformative, and the far more change between say 1890 and 1950 than any changes between 1950 and now, if you think of the lives of ordinary people. So I think it's a mistake to think that the change has been rapid. It's been one very powerful technology based on the silicon chip, which has changed, but others haven't changed. And to give an example, you mentioned flight. It was 50 years between Alcock and Brown's first transatlantic flight in, I think, 1919, and the first flight of the jumbo jet, 1969. And in the 50 years since then, we still have the jumbo jet. There's been no change in civilian flight, except it's become rather less pleasant and less comfortable. There'd be no advantage. Concorde came and went, and so there. So I would make a hazard that the iPhones we'll use in 20 or 30 years won't be very different from those we have now, which has been this surge of development. But the iPhone 11 is complicated enough for anyone, and then it might level off. So I think we're going to see a leveling off of some technologies, but I think in the biological area, we're going to see some resurgence of serious new technologies.
Towards the end, you mentioned that the human being is not the ultimate in evolution. It's not the climax of evolution.
Yes.
But here is a question. One of the viewers wants to know, is it likely that life on Earth will become extinct one of these days?
Well, it could. I don't know. But the point I wanted to make is that it's going to be possible to redesign human beings by modifying their genetic code. And by the end of the century, I think we'll know how to do that, and we'll understand the human genome better. And it might even become possible to have a machine which has some sort of human qualities. And so post-human evolution could happen. I think it may happen first on Mars, where there are no impediments. I would hope that there are constraints which make our Earth a better place to live, less pollution, etc., but don't change us too much. But of course, that's still talking on the timescale of centuries. If we think on timescales of billions of years, then we've no idea what will happen at all. Because once we have technological change, then that happens on a timescale of centuries or even less, whereas Darwinian changes happen on a timescale of hundreds of thousands or millions of years. So any future changes are going to be far, far faster than the ones in the past, but the amount of time available is even longer. So we just can't possibly predict. And of course, we don't know what's out there already. We may discover evidence for advanced kind of intelligence, and we may detect them, or they may be living contemplative lives under some cosmic ocean, not communicating with us. We don't know what's out there. But it's important that the cosmological timescales are vastly longer than technological timescales. So we just can't predict the future. But the Earth, we know, will remain habitable for at least 1 billion years. And let's hope that we don't prematurely snuff out the life on it.
Could global warming and climate change have a catastrophic effect on the life?
I think it could. I mean, if you take the worst case scenario, by the end of a century, this would push up global temperatures by on average 6 degrees centigrade. And of course, that's just an index for massive change in weather patterns, and parts would warm more than that. And so it won't make the world completely uninhabitable. It'll make the world much less pleasant. Everyone will have to live like it is in parts of the Middle East, or the Death Valley in California, where the temperature reached 54 degrees just recently. So it'll make life less comfortable, but it won't wipe out life. But it'll just be a degradation of the life we're used to.
What are your thoughts on life which is not based on carbon and oxygen? One of the viewers wants to know.
Well, of course, that's a very interesting question, because, as I said, we don't understand the detailed chemistry which led to the first life. And the good thing about that is that that's now a serious problem. I mean, it used to be a problem put in the too difficult box. There was this Urey Miller experiment nearly 60 years ago, and people still talked about that. There hadn't been much work done on the subject, but now there are very serious people, some in Cambridge, who are working on this topic. So I think we will have a better idea on how life began. And that work should tell us two things. It should tell us, first, how likely it is. Secondly, it will tell us, is there something very special about DNA and RNA, etc., or could you imagine life in other ways? I mean, and that affects what we might find in the solar system, because if you've seen pictures of Titan, which is one of Jupiter's moons, it looks rather nice. There are lakes and rivers, but they are lakes and rivers of liquid methane. The temperature is minus 160 degrees. So you can't have any water-based life, but maybe methane-based life could exist then, and we'd like to know that. And let me mention one other thing. Looking for any kind of life elsewhere in our solar system, evidence on Mars, or even more evidence on Europa or Enceladus, finding anything, that's crucially important, because if we can infer that life emerged twice independently within one solar system, it immediately says it can't be a rare fluke, and it must exist in a billion places in the galaxy. So that would be a really transformative discovery, because at the moment, it's logically possible that life was such a fluke, it only happened here on Earth, nowhere else. But if we find it twice in our solar system, that immediately says it must exist in a billion places. And that'll be a huge transformation and a huge boost to what's already an exciting field of science.
Going back to artificial intelligence, is there a need to regulate it? Are there bodies trying to regulate artificial intelligence development?
I think very much so, simply because it's being used in context which is an invasion of our privacy, face recognition, for instance, and also it's being used in context where its decisions are important to us as humans, but they may be unreliable. For instance, face recognition, it's been shown that the machine can be completely confused if you make just a tiny change in a face. It then just completely classifies it differently. And ditto, there'd be a problem with self-driving cars. People have shown that if you change the wording on some notice very slightly, it completely screws up the system. So I think there are problems with the use of AI systems, and also at the geopolitical level, we need a international regulator, because they're at the moment dominated by these global conglomerates, and it's very hard to tax them adequately and very hard to regulate them adequately at the national level. So just as we have the International Atomic Energy Agency and etc., and the aviation is monitored internationally, we probably need new international bodies in order to not only to tax these big companies fairly, but also to regulate their use so it doesn't invade our privacy.
And the questions are literally pouring in, and we have just a couple of minutes. I should hand over after that. So here are two questions which are unrelated to what you spoke about today. One of the questions is, Roger Penrose says that consciousness may not be possible with sheer computation. You need something else. Given that, what is your take on artificial self-aware intelligence?
I'm not an expert, but I think this is a very, very important question. I mean, the question of whether intelligence is an emergent property which any sufficiently complex network would have. I mean, I think to have anything that we call human-like intelligence, it's got to actually be able to interact with the external world by its senses, as we have. So it may not happen. But I think it's very important because, to quote an anecdote, I wrote a newspaper op-ed on this. I talked about posthumans probably being electronic rather than flesh and blood, spreading through the universe beyond us. And there were two kinds of response. Some people said, isn't this wonderful? These are more advanced things. Whereas others said, maybe these aren't conscious. And wouldn't it be tragic if there was no conscious entity able to appreciate the wonder and beauty of nature? And I think it's a very, very important question. Does self-awareness emerge in a complicated machine automatically, or is it special to the flesh and blood and sense organs of human beings? So I think it's a very important question, and it does affect very much one's reaction to these far future scenarios.
Lord Rees, you are Astronomer Royal of England, after all. So for the last question, let's go away from this. And a viewer wants to know, do you believe in parallel universes?
Well, I mean, I think the answer is we don't know. And it's, I would say, as a matter of principle, it's a mistake to have very firm dogmatic views on things which are uncertain. But what I can say is that there are some theories of the Big Bang which naturally give rise to not just one Big Bang, but a whole lot of them, the so-called multiverse idea. This is a possibility. And there are other ideas that there may be separate three-dimensional spaces embedded in a fourth dimension. So there are lots of ideas, and we don't know which of them is correct. So there are some theories where there will be just one universe. There's some where there could be separate ones. And then there's a second question. If there were other Big Bangs that gave rise to other expanding cosmoses, would they be governed by the same laws of nature? Would the atoms exist with the same strength? Would the nuclear forces and gravity be the same or not? And this is another question. According to some string theory, they would have different low energy physics, different atomic laws, etc. And they may be stillborn and sterile because complexity couldn't emerge. For instance, if you don't have any periodic table, you can't have complex chemistry. If gravity is too strong, anything big enough to be complex is crushed. So there are two questions. One is there one Big Bang or many? And second, if there are many Big Bangs, are they all like ours, or do some of them have very different physics governing them so that they evolve very different and in many cases are perhaps sterile or stillborn because no complexity can emerge? So I think these are possibilities. And so as to what I believe, I think it's a mistake to have any beliefs. But let me just quote an anecdote to finish with. I was asked this question at a conference at Stanford University, where Andre Linde was one of the other speakers, and he's the person who's promoted an idea called eternal inflation with many Big Bangs, etc. And the chairman, who was Bob Kirshner, you may know, Srini, he said, how much would you bet on this idea? On the level, would you bet your goldfish or your dog or your life? And I said I was nearly at the dog level. And Andre Linde said, well, he spent 25 years developing this idea of eternal inflation, so he'd bet his life on it. And then afterwards, Steven Weinberg, the great theorist, was asked what was his view. He said he'd happily bet Martin Rees's dog and Andre Linde's life. So we should,
Martin.
we should be open-minded on these questions. It's a serious scientific question, not just metaphysics, but we don't know the answer yet. And of course, as a final word, there may be some important questions which are beyond our capacity to answer, because a monkey can't understand quantum theory, and there's no particular reason to think that our brains are matched in their unaided form to understanding the most complex and important aspects of reality. So we've got to be open-minded about that too.
Thank you very much, Martin. I now hand over to Dr. Sushila Venkatraman to formally thank you and close the meeting.
Thank you very much. Lord Rees, as you know, the audience reaction tells us this has been an absolutely fascinating talk. We've heard that from so many of our viewers today. And it's also been extremely thought-provoking in several ways. Professor Srinivasan, your conversation has been absolutely wonderful. And the way you've been able to pick up and ask some very key, bring up some very key issues has been wonderful. So thank you both ever so much for being part of today's webinar. We are really honored to have had both of you here. Just a few takeaways that I would like to summarize. Lord Rees started by saying that for the first time in 45 million centuries of life, the human species holds the long-term future of the Earth in its hands. There is enough for everyone's needs, but not for their greed. And then he went on to talk about several aspects of where things, the big shifts are likely to happen, where the big impact is likely to happen. The first he talked about is a change in diet. And then we had some very interesting discussion ending up with, again, a technological solution, if you like, with artificial meat and so on. The second aspect was around the possibility of migration and war unless the gaps between nations is reduced and there is sufficient redistribution of resources to enable all of us to have a reasonable life. We are facing an ecological shock, and we need to understand the interdependency between different species of life. And also, if we don't take steps very urgently, and again, Professor Srinivasan brought this up in terms of what have we learned from the lockdown and the quick reversal of environmental situations that we have seen during this time. So if we don't understand that this interdependence of different life species, species of life, if we don't understand what that is about and take steps very urgently, we may actually trigger a mass extinction of some more species. And that would be spelling complete disaster for the planet. Lord Rees then talked about climate change and said that this is for real. It's not an imaginary thing. There is no need for debate about whether climate change or not. This century is indeed the last chance that we have to avoid getting to the tipping point that might result in an irreversible destruction of the planet. So again, the key message is it is in our hands to do something about it. And finally, he talked about the need for resilient networks because our lives are so intertwined and so dependent on technology now. And then he went on to talk about looking at a little bit of crystal gazing, if you like, into the future, the kind of key technologies, a few key technologies, 2050 and beyond. Mainly AI, robotics, biotech space. He talked about the good and the bad. And again, a few key takeaways. Technological solutions for short-term issues can have long-term negative impact unless we design them and implement them in a way that takes care of the long-term as well. how can we legislate and manage globally rather than at a national level? Because what happens in the world of technology today is global. It is no longer restricted to the national boundaries as we know them. We need to be responsible in creating and harnessing technology. He also took us into a little bit of a gaze into the future and talked about the possibility of people settling on other planets, but that does not mean that we have less of a responsibility for our planet here and now. So just one other aspect of the kind of shifts that are being caused by technology. The first is power shifting from governments to technology companies or private hands. The second is about crime, the nature of crime. It is now something that is impinging on our freedom, our privacy, as well as our personal security. The redistribution of wealth that is now taking place as technology sucks money into specific areas, into a few hands. He talked a lot about ethical considerations and about things like, especially when it comes to areas like artificial life extension. And finally, he said that Darwinian evolution, which is what we've been sort of which is what we've known all this while, is going to be superseded by technological evolution. And that is going to make going to bring a lot of changes into the way we think about and we understand where things are going and the kind of actions that we need to take. And then he ended with a perspective of life on Earth. And he asked these questions about, will the post-human be of the kind of life form that we have known, or would it be electronic? Either way, we must understand that we are only part of an evolution, and we have a huge responsibility that we are carrying now. Einstein said that we are but a speck in an unfathomable large universe. And today, Lord Rees, your talk has explained to us why we should feel humble and why we should understand that we have this huge responsibility to the Earth, to the planet, to ourselves, to the species, and to the other species that we coexist with. And this responsibility is larger than a responsibility that any previous generation has carried with it. So with this, I would like to once again thank our speakers, both for having participated in today's webinar and made it so interesting for all of us and so valuable, as well as for having been part of releasing the first set of webinars in book form. For our viewers, thank you very much for being part of this, for bringing up those questions and participating. The books are we're going to be loading them up on a drive somewhere, and we will be sending out the link to it.
We have lost
Mailing list, but we will continue to transfer and have webinars up. In any case, every one of our webinars is up on the IITACB channel. Please do feel free to look at it. And if you've missed parts of it, you will find it all there. And please feel free to spread the word around. So once again, thank you all very much. Goodbye.
Yes, thank you very much indeed.
Thank you, Lord Rees.